Hello students, welcome back to the another session of our artificial intelligence. Right now we are covering the different searching strategy used by the agent to find its goal state. So in this video we are going to cover depth limit, depth first search. So it is, we can say it is a one type or next version of the depth first search. Let us understand how it's perform its operation. Before going to the depth limit, first we have to understand how depth first search operation is going to be performed in a tree. It can be used for the graph as well as it can be used for the tree. In last video, I have already covered the details of the depth first search algorithm. In the description section, I also put the link. You can go through. But before going to the depth limit, we have to understand how its operation is going to be performed. So what is the drawback? Why we have to go to the depth limit? So in this case, what happened? Searching and node is present inside the tree. That's the main objective goal node. So for example, our goal node is the F. So now our goal node is the F. So what happened? We have to searching in which case that the depth first search. By the name depth first means it will be to start from the anyhow in a tree it will start from the root node. Then we have to traverse the deepest node. Means from the root node we have to traverse any one children. So for A, B and C is present, both the children is present, we can traverse B or we can traverse the C. It is our choice. For example, the sequence. For example, I select this one, this left side. So what happened for each and every node, we have to select like that. So now we visited the A. Whenever we visit a node, we have to check whether it is a goal node or not. So now agent starts searching from the A root node, A equal to F, no. Then it will be traversed to the child. So child means B and C. So if there is no children, then what happened? It will go back. It is here. The depth first search also use the backtracking means from one node to the child node. If there is no child, it will go to the sibling. If there is no sibling, then it will go back to the its parents, and that parents should be unvisited. Visited parents we cannot go to. So now A is the visited one, so we make the A as a visited. So first we have to traverse, that is the visited node A. Then we have to move to the, for example, B. Now this is B. B is F. No, it is not a goal node. If it is not a goal, is there any child node is present? Yes, there is a child node is present. So we have to move to this one. And we have to make the D as a visited node. Then from D to F we have to. Yes, there is a child. So we have to move this one. H. H is a goal node. No, H is not a goal node. If there is no goal node and there is a child. So we have to traverse this child. Then what happened? I is not goal node because our goal node is the F. Then I, here what happened? No children. If there is no children, then what happened? It will go to the sibling, that is J. Now J does not have any children. If does not have children, then what happened? Here the backtrack algorithm means it will back to the parents node. So whenever it go back to the parents node H, what happened? H is already visited. So this is the list of visited node. So these are the visited node. H is visited now. It go back to the its parents because H does not have any siblings. So it will go back to the parents. Parents D means D is already visited. D is already visited. So again what happened? It will search whether any sibling. Yes, it is sibling is present. So if sibling is present means what happened now? J go back to the H. So now E is the goal node. No, F is the goal node. Then what happened? Then what happened? E does not have any children. Sibling also visited. No unvisited sibling. Then what happened? Go back to parents A, B. So here it is already visited. So B, C is there. Yes, C is there. So what happened? It will go to the C. C is the goal node. No, C is not a goal node. Then what happened? It will move to this one, F. Now F is a goal node. Yes, F is a goal node. So now here the agent stop its traverse. And what is the path? Path is the A, B, D. H, I, then E, then C, then F. Now just think about this is the level 0, level 1, level 2. Level 2, data is already present. We are unnecessarily traverse this way or not? If I start traversing this way, means instead of selecting this one, if I select this one, for example, I select this one, means from A to C, it can be possible. Then what happened? Path is A to C, then A to C to G, C to G, then G to F. So we got the result. But here, how much? This much traverse is required. So this is the drawback of the depth first search algorithm. Or if there is more node is present, for example, more node is present. Now our goal node is here and we are traversing, and at that time there is a chances of infinity loop. So at that time what happened? Solution is there, goal state is there, but we could not able to reach it. This is the main drawback of the depth first search algorithm. So what we have to do? What is the solution? Depth limit equal to 2. So here depth is 0, depth is 1, depth is 2. So now what happened? If we traverse this way like the depth first search, so it will go to children, then it will go to children. Now check depth of this node is 2 right now. If it is 2 means it will not go to the for the next children. No, means it is the cutoff point. So here what happened? It will traverse to the sibling. Is there is the goal node? No, goal node is the our F is the goal node. So our F is the goal node means it will again go back to backtracking algorithm, then it will go to C. So what happened? It will go to the C, then from C to it will go to the F. So what is the path right now? A, B, D, E, C and F. So we got the result. Now we have to understand details of the depth limit search. So it is a uninformed search or blind search algorithm, as we are already know. It is a one type of searching algorithm where no information is given or prior information is not given, such as the what is the path cost, what is the route. Only the information is given how to traverse. That's why it is called as the blind search. Agent started searching blindly without any information. We can say it is a next version of the depth first search algorithm by imposing a limit on the depth of search. In case of the general depth first search algorithm, what happened? We have to go deepest node. But here we don't have to go to the deepest node. We have to search only the go to the node up to the depth limit is provided. It means it is a predefined limit is given. According to that, searching will be proceed. We are already discussed. So the main problem that is the associated with the depth first search algorithm, that is the infinity path, is solved by this algorithm. There are two conditions generally used to terminate the depth limit depth first search algorithm. First one is the standard failure value, which is indicate that the problem does not have any solution. Second category is that condition is the cutoff failure value. So what it going to do? It defines no solution for the problem with the given depth. So cutoff failure means solution is there, but for example depth limit is 2, but the node is present at the depth fifth. So at that time what happened? Failure occurs due to of cutoff, but the solution is there for this problem. So this called as the cutoff failure value. Next we have to understand how the depth first limit next version, that is the depth limit, is going to be perform its operation. Generally here what happened? It performs with the 5 step. First step is the initialization. What is initialization? Initialization means that first step is the initialization. So here what happened? It start with the root node of tree or starting node of a graph. If it is a graph, if the graph is given and the starting node is given, then it's okay. We have to start from this. If the starting node information is not given, then randomly we have to select the starting node. But if it is a tree, so it will start from the root node. Next one is the exploration. Exploration means that traversing the tree or graph, exploring each node's children. Means from A node to we have to explore either B or C. Then we have to check the depth check. Next step we have to follow, that is the depth check. It is if the current depth is exceed the set limit. Then what happens? Stop the exploring and path and start the backtracking. For example, here the depth limit is given, that is 3. So this is the depth is here 0. This node depth is 1. This node depth is 2. This node is 3. Next question, how we calculated a depth? Depth of a node is the number of edges present in the path from root node to that node. For example, this is the A. So A depth is 0 because it is the root node. So there is no edges. If you go to the C, how many number of edges? Only one edges to from the root node for the node C. That's why depth is 1. Here the for G node what happened? Depth is how many number of edges? 1, 2. So that's why the depth is 2. Here 1, 2, 3. So depth is 3. So this is the way we have calculated the depth. So in this case, what happened? Then we have to check if a node already reached the goal node. For example, my goal node is for example J. Then what happened? We have to depth limit is 3. So first what happened? Initialization, then the exploration run. So it explores the children. Then it will go to this one. Now again it will go to this one. Yes, H is the 3. After that means depth check. Each and every item, if the current depth exceed right now the limit, because then what happened? It will stop the exploring. So further it will not go explore. Start its backtracking, means it is already a visited node, so it will go to this node. After this node, what happened? Parent and sibling already visited, this one is already visited, so it will go to this node. Then it will go to, after C, what happened? It will go to this node. Then it will go to this node. Then it will go to this node. After that, what happened? Here, after reaching the P, depth limit is C. So after that, it will not go to the next. So here it will stop. Applications of depth limit, depth first search. First one is the network routing algorithm. So in case of depth limit search, it can be implemented to compute the path between the node. So it can be used for the find out the path between two nodes in computer network, restricting the number of hops to prevent the loop. So it can be used here. Next one is the we can able to data the depth limit search can be used to solve the puzzle such as the 8 puzzle problem, or it can be solved from the Sudoku games by manipulating the possible moves of a fixed number of times that reduce the how many steps are taken in the search algorithm. So here also it can be used. Next application we can able to use, that is the gameplay. So in case of artificial intelligence for game, depth limit can be used to plan forward a number of few moves up to a certain level of depth to help to decide how much effort to put into a given decision. So for that also we can able to use it. Next one is the path finding in robotics. So here what happened, the depth first search limit, you also if you go for the depth first, it will go to infinity loop. So here we can able use the depth limit. So it is used for monotonic motion planning of robots in presence of the obstacles. By imposing the restriction on the depth, it makes the robot stop after exploring a particular depth of an area and restricting to the robot from the too much wandering. So no need to wander too much. It put a restriction. So these are the application of the depth limit. It can be used to find out the distance between two vertices. There are so many applications is present. So let's start the to discuss about the time complexity. Time complexity means how much times required to execute the algorithm. It is the order of b to the power l. So what is the b? B is the branching factor of the search. Next question, what is the branching factor? Branching factor is defined as the average number of children per node in the tree or a graph. So per individual node, how much it number of children is present. L is the depth limit, because here we are not going to the, in case of the depth first search, what happened? B to the power D. The D is the depth, but here our depth is limit. So it is B to the power L. L is the depth limit. Next one is the space complexity. So space complexity here, it is the order of B to the power L, where B is the branching factor, L is the depth limit. Next question, whether it is give us the optimal solution or no, it is not optimal, because the depth limit search can be as a special case of the depth first search, but it cannot be optimal even the depth limit is greater than the depth. It cannot be provide us the optimal solution. The next one is completeness. A depth limit search algorithm is a complete in general, except the case when the goal node is the shallowest node and it is beyond the depth limit, that is the one is greater than the, that is the depth limit is less than the D. At that time it is possible, but in this case we never reach the goal node. It is true. We cannot say it is a complete, because we are already go through the previous example where the solution is present due to a depth limit, we could not able to reach the goal node. So what are the advantage of this algorithm? It is memory efficient, because depth limit is there, so very less amount of memory is required. What are the drawbacks? So first one is it is incomplete. We may not reach the solution even though there is solution is available. This is the main drawback. And it does not give us the optimal solution even more than solution is available. Even though a solution is there, but we cannot able to get the optimal solution. This is the all about the depth first search algorithm. Hope you are able to understand the concept. Thanks for watching the video. Please subscribe the channel, like the channel, share the channel. Thank you.